A determinant is a rectangular array of numbers, or I should say a square array of numbers, and here's one right here. These symbols right here that look like large absolute value symbols, they stand for the determinant of this array of numbers. Now the definition for this determinant is what you get when you cross multiply here, 3 times 7, and subtract from that what you get when you multiply up here, negative 2 times 5. So this determinant is defined to be that product minus that product. So I end up with 21 plus 10, which is equal to 31. Now you'll see that these determinants can be used to solve systems of equations. They don't make a lot of sense right now, but as we go on to the next section, you'll see you can actually use them to solve systems of equations. So right now you don't want to question the definition too much. You just want to see if you can apply the definition to these determinants and successfully get the correct answer. Here's another problem. Find x if x squared 2x1, that determinant, is equal to 8. Well, let's cross multiply. X squared times 1 is x squared. X times 2 is 2x. And I'm sorry, I have to subtract that. So it's this product right here minus this product here, and that's equal to 8. So here's the determinant when I evaluate it, and then here's 8 on the other side. Quadratic equation, x squared minus 2x minus 8 equals 0 when I put it in standard form. Factor it, x minus 4, x plus 2 is equal to 0. So x is equal to 4, or x is equal to negative 2. Either one of those values of x, when I substitute into this determinant, will give me a determinant whose value is 8. Now the next thing we want to do is try a 3 by 3 determinant, a little more complicated process. Here's our problem. We're going to evaluate this determinant by using what's called expansion by minors. So first thing I'm going to do is draw a sign array, which is just a determinant of plus and minus signs. It always starts with a plus sign in the upper left-hand corner, and then it alternates plus and minus across every row and down every column. I want as many entries here as there are over here. So it's going to be plus, minus, plus, minus, plus, minus, and then plus, minus, plus. Now, once we have this sign array, then what we can do is pick any row or column in this determinant to expand across. Let's pick column, or I should say row number 2. So what I do is I go over to the sign array, and I pick the signs that are in the same row as the row I'm expanding across. So minus, plus, minus. Then after each one of those, I write down the numbers in this row, 2, 0, and 1. Now each of these is multiplied by a 2 by 2 determinant, and that 2 by 2 determinant is the determinant I get when I cross out the row and column that that specific number is in. So when it comes to this number right here, I cross out that row and that column. The determinant that's left is 3, negative 2, negative 1, 1. So 3, negative 2, negative 1, 1. I go to this element right here, I cross out that row and that column. What's left is 1, negative 2, 4, 1. Again, that's this element right here, 0. I cross out the row and column that it's in and look at the determinant that's left. Now I go to the last element, which is 1. I cross out the row and column that it's in. What's left is 1, 3, 4, negative 1. So 1, 3, 4, negative 1. Now, the rest is simply a matter of evaluating these determinants. 3 times 1 is 3. Subtract negative 1 times negative 2, positive 2. Plus 0 times, we really don't care because 0 times anything will be 0. Minus 1 times, that will be negative 1. Minus 3 times 4 is 12. So let's see what we have. We have negative 2 times 1 plus 0 minus 1 times negative 13. So I end up with negative 2 plus 13, that's 11. So the value of this determinant right here is 11. This method that I've used to find it is called expansion by minors. So I first draw the sign array, and then I choose any row or column to expand across. I use the signs from the sign array in front here. Then I write down the numbers in the row or column exactly like they are, and then I multiply by these 2 by 2 determinants that I get by crossing out the row and column that that specific element is in. What's interesting about this is if you do the same thing across row 1, or down column 2 or down column 3, you get the exact same number. This determinant is 11 no matter which row or column you expand across.